we'll cover section 1.5 more on slope. We're going to talk about parallel and perpendicular lines first. So parallel lines, we have three conditions here. Well, 1 and 2 are the same thing. We have if two non-vertical lines are parallel, then they have the same slope. Same slope. Why do you guys think we're making that non-vertical lines exception? Very nice. So vertical lines have an undefined slope, right? And so if we have, let's say, x equals 2 and we have x equals -5, we know that the slope for both of them is undefined. However, we cannot say that undefined equals undefined. That's just like nonsense, okay? Because remember, undefined, that does not give you a specific number, so you cannot say one is equal to the other, all right? So that's why we make that distinction there. Now, I want to point something out. For those of you who already took geometry or you are taking geometry, there's something called conditional statements. And so those go like this. You take the first part and we assign a letter, in this case, lowercase p. And then the second statement, they're also known as if statements. The second statement will be q. So what this is saying is that if p, then q. If you're taking geometry this semester, you will cover this pretty soon. Now, if you guys look at statement number 2, it's almost the same. It's just reverse, right? So we call that the converse. So that will be if q, then p. And so that says if two distinct non-vertical lines have the same slope, now they're mentioning same slope first, so if they have the same slope, then by default they are parallel, all right? Now number 3, it covers vertical lines. So we're not gonna say their slopes are equal, we're just gonna say vertical lines are parallel. And that's it. Now I have a question for all of you. What about horizontal lines? Why they're not talking about those then? Or are they? Yes, they are. They're non-vertical, right? So yes. That horizontal lines are covered by 1 and 2. All right, so let's look at the first example here. And we have write an equation of the line passing through the point -3, 1 that is parallel to this line. Okay, so here we're talking about two lines, and I like to make a distinction here, so I like to do this. Line 1 is the one given to you, and line 2 is the one that you need to find. Okay? Now, we know that we want line 2 to be parallel to line 1. So if we want it to be parallel, yes?
Wouldn't you just be like, if you want it parallel, you just change the line Intercept?
Yeah, same slope. They will have same slope and different y-intercept. So what is the slope of line 1? 2 is the coefficient of the x. So the slope of line 1 is equal to 2. Now here, just to distinguish from line 1 and 2, I'm going to call this slope 1. Now we want it to be parallel to the second line, so the slope for that one is also 2, right? Same slope. Parallel lines, same slope. Now we want the line, the one that we're looking for, this one, to pass through this point. So we will use the point -3, 1. Okay. Now I'm going to use the point slope formula. Y minus y1 is equal to m times x minus x sub 1. And so let's go ahead and start substituting. Remember that your variables y and x they remain as variables, right? You don't change those for a number. Okay, so substitute your numbers. We have y minus y sub 1 equals m. M is here. And then we will have x minus x sub 1, which is negative 3. Okay, so y minus 1 is equal to 2 times, and here we have negative times a negative. What does that mean? Positive, positive 3. So if we were asked to give our answer in point slope, that will be the answer, point slope form. Okay. Yes.
I'm going to pick up your laptop later, okay? Because I'm going to take it back to the shop.
Okay.
Because I'm having a hard time activating the software.
All right, and so what we are going to do, if you guys notice, the question is also asking us to give the answer in slope-intercept form, right? So we're going to do both. And so that will be y minus 1. I'm going to distribute the 2, so 2 times x, and then 2 times 3. Now we just need to solve for y. So we need to take care of that negative 1. So this negative 1, if we move it to the other side, will turn into a positive 1. And we end up with 2x plus 7. So that means that the equation for line 2 in slope-intercept form is 2x plus 7. I'm going to write it here, 2x plus 7. And you guys noticed Ezekiel was talking about they will have the same slope, but they will have a different y-intercept, right? That's another characteristic of parallel lines. All right. Question before I move on to the next problem. Okay, next slide. Okay, now perpendicular lines. When you were taking algebra 2, we were using like something like an easy statement. But before we get to that one, let's look at the preconditions here. And again, 1 and 2 are the same. One is the converse of the other. Remember, switch the order. Okay, so we have if 2 non-vertical lines, again, are perpendicular, then the product, remember that it means multiplication, the product of their slopes is equal to negative 1. Statement number 2 is the same, but in reverse. So if the product of the slopes, if the product of the slopes of 2 lines is negative 1, then the lines are perpendicular. We also have the third one, a horizontal line and a vertical line are perpendicular. Okay? You don't even need to do anything with the slopes. They are perpendicular. Okay. Now, the statement that we used to refer to goes like this. So one line is perpendicular to another line if its slope is the negative reciprocal. You guys remember that? Of the slope of the other line. Okay, so let's see what we mean by that. I'm going to get some more space here. Let's find some room on your paper. So for example, if we have a slope that it is equal to 1/2.
Can you just reread it?
Oh, yes. One line is perpendicular to another line if the slope is the negative reciprocal of the slope of the other line.
Okay, thank you.
You're welcome. So if our first slope is equal to positive 1/2, that means that the slope of the line perpendicular to it, it will be 2/1. That will be the reciprocal. But the part that says the negative reciprocal, that means that we need to change the sign to its opposite sign. So it will be negative 2/1. Now if we have another one, let's say negative 3/5. Thank you.
I'll be back.
Oh,
I'm gonna pick up the.
okay. So if we have negative 3/5, Lorenzo, what will be the slope of the line perpendicular to it? Mm-hmm. Should I leave it like that?
Yeah.
Okay, yes, leave it like that. So in this case, we went from negative to positive. All right? So that's what we mean by negative reciprocal. Okay, now let's go back to the problem. Bless you. Okay, so find the slope of any line that is perpendicular to the line whose equation is x plus 4y minus 8. Now, first thing that we need to do, and don't tell me that the slope is 1, okay? That you cannot do that. That's a no-no. Okay? First, you need to solve that. You need to go from general form to what form? Slope to intercept. Okay. So we want to do that by solving for y. So 4y is equal to this positive x. If I move it across, or it will do the inverse operation, so negative x, it will be subtracting. The negative 8 is subtracting to the y, so if I move it across, it will be adding, so it will be plus 8. And then finally, the 4 is multiplying, so we need to divide. So negative x plus 8 divided by 4, the whole thing. So here we will have negative x divided by 4 and positive 8 divided by 4. So this will be, remember, what will be the coefficient of the negative x up here? A negative 1, right? So it will be negative 1 over 4 times x. And then 8 divided by 4, that is equal to 2. However, what we care about here is the slope, right? So we're going to say that the slope of this line is equal to negative 1/4. So to answer the question, find the slope of any line that is perpendicular. I'm going to call that m sub 2. So what will be the negative reciprocal of that event? You've been so quiet today.
The negative, the 4/1.
Positive or negative?
Positive.
Positive. Very good. So that will be, those two are slopes of perpendicular lines. Now let's go to part B. And part B, we need to write the equation of a line passing through the point 3 comma negative 5. And we want it to be perpendicular to this line, right? The first one that was given to us. So we already know that. That told us the slope for that one will have to be 4/1, or simply just 4. So let's go ahead and use the point slope formula. I know that some of you have a way to find the equation by using this, and then you substitute. I don't even know what you substitute. I never learned how to do that. If you don't know what I'm talking about, don't worry about it. If you know what I'm talking about, you may use that form if you want to. Huh? It's a no. Okay, so let's use the formula y minus y sub 1 is equal to m times x minus x sub 1. And so here we will have y minus, we take the y sub 1 from here, that's negative 5 from the point. The m we know is a 4. X minus, and we take the x sub 1 from here, 3. Okay, so here negative times negative is positive. And if we want the, you guys notice we need to our answer in general form. Okay. All right. We can do that, right? Okay, so 4 times x, 4. And then 4 times negative 3? All right. So will that be in general form? No, right? General form, just so you remember, it looks like this, ax plus by plus c, and then what do we have it equaling to? 0. Okay, so what we need to do is move all of our terms to one side. Okay. It doesn't matter which side. What would you guys prefer to do? Okay. So y plus 5, I'm going to write what I have first. And then the positive 4x, move it across, becomes negative 4x. Negative 12, we move it across, it becomes positive 12. And that is equal to 0. Now we're going to combine like terms, so we have 5 plus 12. Let's go ahead and write our terms in order, starting with the x term, so that would be negative 4x plus y. And then combine the constant terms, so that will be plus 17. Yep, and that's it. Your book doesn't require to make a and b integers or positive. It simply states that they are real numbers, so we're good there. Okay, next problem.
For the second test for general form?
Oh, good question. Genesis is asking me if on the test I will ask for general form. Yeah? Maybe. Huh? I have a calendar on my webpage, but I need to adjust it because I forgot that you guys didn't have school on Friday. So it's gonna be after we cover chapter 1, Michelle. After we're done with chapter 1. Okay. So we still have time, but still make sure you guys keep up with your homework. All right, next problem. We're going to look at slope as the rate of change. So you guys notice here we have 2 lines. They're 2 independent lines. Would you guys say they're parallel?
No.
No, they kind of look like it, but if we extend them, they will eventually cross, right? Okay.
Oh, okay.
Yeah? All right. Now, for the purpose of this problem, we're going to be finding the slope of the line segment that represents women. Okay?
But do they extend? Because they have a little not.
Well, that's because they only have data from 1990 to 2008, or data, as Robert might say. Right? Okay. So we're going to be looking at the line on top. Right? So we're going to use this point here and this point here. And then we're going to describe what the slope represents. All right, so we start with, I would like to, well, let me write the formula. Okay. So the second point, I'm going to consider that the 2008. So, by the way, the horizontal axis is the independent variable, which represents the years. I'm sorry, time in years. And then we have the vertical axis label, right? And that represents in millions the number of people who were living alone. So we have the Y value here is 18.3 million a year. And minus the other Y value, which is 14 million. For our X values will be the year 2008 minus the year 1990. Okay, and this will be 4.3 divided by 18. Okay, and that is approximately 0.24 over 1. Okay, so now we want to interpret what that means in words. Anyone who would like to explain that? Alexis? I'll give you a little head start. So every year, would you guys say that it increased or decreased? Increase. What?
So every year it increases by 0.24.
Okay. So every year, let's say the number of women increases by 0.24 million. Okay. Okay, good question, Peru. I was kind of expecting you to ask me that. Okay, so let's convert it. Do it on the side of your paper. So 0.24 million will be 2,400,000, right? Or that could be 24. Okay, let's skip that one, and then if we add another 0, that will be 240,000, right? Yes?
Are you recording? Yeah.
Yeah. I'll check, cause yeah, I think so. All right. So, do you guys think that at this time in 2015, that number will be higher than that, 18.3?
No.
Yes. Maybe we could do. I'll find out just to make sure. Yes, Viviani.
I know I'm asking you, but you're supposed to talking, but it's teaching us, and she wants to know if this is real.
Yes, they are real. All the graphs that come from the book are real, and if you check on the ebook, you could find the source. Yes, a lot of their information comes from the U.S. Census Bureau. Mm-hmm. I would say yes. If we extend that, of course, we can make a prediction. But think about it. Up to this time, more women graduate from college than men.
Yes.
Sorry, guys.
That's cool. They can have it.
So one day we'll be ruling the world, right?
Did you know that now they're creating programs for men to go to college?
Oh, wow. Like scholarships just for men?
Yeah.
Wow.
So,
Okay. All right. So moving on, guys. Oh, it's already time. Wait. Okay. So I am gonna continue recording, and you are responsible for watching this video. Okay?